Hello, one and all present here. This is Amit Kumar Singh, and welcome to my class on circle. So, this is my session number two. I believe you have seen my previous video on circles. So, already when we talk about circle is a very important concept, which is important for all the students who are preparing for CBSE and ICSE uh, portions of mathematics for the class 9th and class 10th. And at the same time, this is important for all the students who are preparing for competitive exam, where the geometry portion is going to come. So in the previous session, what we have done, we have discussed the concept of circle, and then we talked about radius, we talked about diameter, we talked about arc, we talked about segment, we talked about sector. Okay, and now going further, discussing on circle, so we'll discuss the important theorems. So one few theorems which we have discussed in the previous session was that if you have a circle and there's a chord, suppose AB is the chord on the circle, and from the center, if you draw a line, and from the center, if you draw a line which is perpendicular on the circle, then definitely that line will bisect the chord. Remember that whenever you talk about circle, remember this. So a perpendicular line drawn from the center of the circle on the chord always bisect the chord. Then next thing what you need to remember is that if there's a line which joins the center of the circle to the midpoint of the chord, then that line is always perpendicular on the chord. Then the third property which you can understand here is that the perpendicular bisector of the chord always passes through the center of the circle. So I believe you have understood this part. Now going further, discussing on circle, we need to understand this part. So here what you need to understand is that the length of the perpendicular from the point to a line is the distance of the line from the point. So we need to understand, going further, whenever we talk about circle and the concept of chords on the circle, you need to understand that the equal chords of the circle develop equal angles at the center, and at the same time, if a chords create an equal angles at the center, definitely that chords would be equal. So this we have studied in the previous sessions. So, then you need to remember that the equal chords of the circles are equidistant from the centers. So remember this. So what we have studied till now is that in circle theorems and all, what we have studied, that the perpendicular line from the center, from the center, perpendicular line from the center on a chord always bisect the chord, always bisect the chord, always bisect the chord. So this is what we have studied. Then we have studied that the a line which bisect the chord, from the center of the circle, from the center of the circle, from the center of the circle, is always perpendicular, Okay, then we have studied, the next thing we have studied here is that the equal chords subtend equal angle at the center, equal chord subtend equal angle, equal chord subtend equal angle at the center, equal chord subtend equal angle at the center. Then going further, we have discussed the converse of this. I hope you understand. Then the next thing is that the equal chords are equidistant from the center. 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 Okay, this is the next thing what we have studied here. So this again you can prove it through congruency. You can prove the same thing for congruency. Okay, this is very easy. Then chords which are equidistant from the centers are equal in length converge of this. The chords which are equidistant from the center, 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 chords which are equidistant from the center are equal, chords which are equidistant from the center are equal. Then if the two intersecting chords make equal angle with the diameter passing through the point of intersection, prove that the chords are equal. This is important here, this concept. So you can see this. So if there are two chords are there, suppose AB and CD, and suppose they make equal angle with the diameter. Suppose PQ is a diameter which is passing through the center of the circle called O, and suppose the angle AEQ is equal to the angle QEM. Okay, so then you have to prove that these chords are equal. So how to prove this? So you can see this. What you do here? 1 minute. Let me see here. 1 minute. Hmm. So here, this is what I'm talking about. Hmm. So you can see this. Suppose this is the circle, and here, so if two intersecting chords are there, which makes if there are two intersecting circles are there. Okay, so nothing can be done. So if you see here, so you can see what you construction you have to do. Draw OL and OM perpendicular here. Now you see this triangle OEL and the triangle OEM. So you can see OL and OM are perpendicular. Okay, so they are 90-degree. You know, it is already given that the angle AEQ will be equal to QED. So that is also given. Okay, and EO is a common side. So EO is the common side. So with that, you can prove that the triangle OLE is congruent to the triangle OME. You can prove very easily that is that the angles is equal. So if two angles are equal, automatically the third angle would be equal only. So A congruency, or by using RHS, anyway you can prove that that this triangle OLE is congruent to the triangle OME. So once you prove that these two triangles are congruent, so you can either use AA or you use RHS congruency, and you can prove that this part. Okay, so once you prove that, now you can say that OL, because the triangles are congruent, so means OL will be equal to OM, and AB will be equal to here. So you can say that AB will be equal to CD. So that is what you need to prove, that why AB is equal to CD. So you here you can see that please understand this part, that you know that so a line from the center of the circle, if it bisect the chord, sorry, if the line from the center of the circle, if that is perpendicular on the chord, then it always bisect the chord. So here if we see here, if we see here what you can do, we can easily prove that this triangle OLE is congruent to the triangle OEM. So once you prove that they are congruent, then you can see that LE will be equal to EM. Then you know that LE will be equal to EM. And then at the same time, there's a one theorem we have studied, that the chords which are equidistant from the center are equal. And if OL is equal to OM, Here if OL is equal to OM, if OL is equal to OM, here if OL is equal to OM, so chords which are equidistant from the center are equal. So there, because OL, because you can prove that the triangle OLE is congruent to the triangle OEM. Once you prove that these two triangles are congruent, it means OL is equal to OM. So the chords which are equidistant from the center are equal. That means AB will be equal to CD. So very easily we can prove it. So we can prove this very easily. Now here we try to solve these questions of exercise. Exercise 10.4, you can see question number 1. This is question number 1. So two circles of radii 5 centimeter and 3 centimeter intersect at 2 points, and the distance between the center is 4 centimeter. Find the length of the common chord. So two circles of radii 5 centimeter and 3 centimeter. Okay, intersect at 2 points. So 1 minute, let me draw this. So these are the two circles. So they intersect at 2 points. Suppose the points are P and Q. So two circles of radii 5 centimeter and 3 centimeter intersect at 2 points, and the distance between the center is 4 centimeter, and the distance, suppose this is O, suppose this is O dash, and the distance between the center is 4 centimeter, and the distance between the center is 4 centimeter, and the distance between the center is 4 centimeter. Find the length. You have to find the length of PQ. So here you have to find the length of PQ. Okay, so here, so suppose I draw a perpendicular line. So if this is a perpendicular line, then it will bisect the chord. Okay, so this is 5, this is 5. Okay, this is X. Okay, and you know that perpendicular line for the center bisect the chord. So this is suppose Y. Okay, and then this would be 3 because the radius is 3, and this would be 4 minus Y. Okay, and the length O dash is equal to 4, that is given. Okay, now you just need to use Pythagoras theorem. So you can see that x square plus y square is 25, is equation 1. Okay, then if you use the other triangle, so you can say that uh, x square plus 4 minus y square, that will be equal to 3 square. Okay, that is equation 2. So I can say that x square plus 16 plus y square minus 8y is equal to 9. So you know that x square plus y square is 25. So 25 plus 16 minus 8y is equal to 9. So that is 41. 41 minus 9 is 32. So 8y is 32. So y is equal to 4. Y is equal to 4. So if y is equal to 4, so you know that x square plus y square is equal to 25. X square plus y square means 4 square is 25. So means the value of x would be equal to 3, no? So the value of x would be 325 minus 16, that is 9. And so the value of x is plus minus 3. So the value of x cannot be negative. So the value of x is 3. So what is the length of PQ? So the PQ is 2x, that will be equal to 6. Any doubt, anyone? Very simple question. So you just need to use basics of concept of circle, and at the same time the basic concepts on Pythagoras theorem will help you to solve this problem. Okay, then question number 2: if two equal chords of the circle intersect, if two equal chords of the circle intersect within the circle, prove that the segment of one chord is equal to the corresponding segment of other chord. So, going further here, if we see this question number 2. So if two equal chords of the circle intersect within the circle, if two equal chords of the circle, if two equal chords, if two equal chords of the circle, suppose this is AB, this is CD, and suppose this is E. So here it is given, that if two equal chord means AB is equal to CD, this is given to you, intersect within the circle. Okay, so they are intersecting at E. To prove that the segment of one chord are equal to the corresponding segment of other chord. So what you have to prove? You have to prove that AE is equal to CE. This is what you need to prove. And then you need to prove a segment of one chord means EB is equal to ED. This is what you need to prove. This is what you need to prove here. So suppose this is the center of the circle. From the center of the circle, draw the perpendicular line. Suppose this is OF and suppose this is OG. Okay. Now the chords are equal. So if the chords are equal, okay, so definitely they would be equidistant from the center because the chords are equal. So they will be equidistant from the center because AB is equal to CD. Now they are equidistant from the center. So then the triangle OFE will be congruent to the triangle OGE. Okay, so if they are equal, so if they are equal, so then from the center, if you draw the perpendicular line, so I can prove that this and this will be equal because I can, when I'm solving, I can prove that the triangle OFE is congruent to the triangle OGE. That I can prove it, no? That I can prove it very easily. So by using SSS congruency, I can prove that they are equal, correct? So 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 by using SSS congruency, because that they are equal chord, so they will be equidistant from the center. So the OF will be equal to OG, and then sorry, 1 minute. So OF will be equal to OG. So here OF will be equal to OG. So here OF will be equal to OG. Then this is 90 degree, and then it's common. So forget our SSS by using RHS congruency. So by using RHS congruency, you can prove that triangle OFE is congruent to the triangle OGE. So how? So that you know that 90 degree because I've drawn a perpendicular line. So I have drawn perpendicular line. So I have drawn perpendicular line from the center. So here OF will be equal to OG because equal chords are equidistant from the center. Then OE is the common and 90 degrees there. So by using RHS congruency, you can prove that they're equal. So if they're equal, then it means EF is equal to EG. So if EF is equal to EG, then 2 times of EF will be equal to 2 times of EG. So that means DE will be equal to EB. That the a line which is drawn from the center, if that line is perpendicular on the chord, it will always bisect the chord. So that is already that the FE is equal to DF and EG is equal to EB, and already you prove that EF is equal to EG. So that means DE will be equal to EB. That you prove that. So once you get that, now how to prove? Now once you get this, now you know that, now we know now we know that So we know that AB is equal to CD. We know that AB is equal to CD. And if now I can say AB minus DE, AB minus sorry AB minus AB minus EB will be equal to CD minus DE, correct now? And AB is equal to CD and EF is equal to DE. That means A will be equal to C. Okay, so I hope you understood this. So question number third, if two equal chords of the circle intersect within the circle, prove that the line joining the point of intersection to the center make the equal angles with the chord. So if two chords of the circle intersect within the circle. Question number third, let me solve question number third. So question number third is this. So if this is a circle, so if two if two question number third, if two equal chord circle intersect within the circle. So can we do on this question? Okay, leave it. So this is AB and this is CD. So here what is given if two equal chords of the circle? What is given? It is given that AB is equal to CD. Okay. 1 minute. Let me draw this CD little bit closer. Suppose this is center O. It is given that AB is equal to CD. So if two equal chords of the circle intersect within the circle, prove that the line joining the point of intersection to the center, line joining the point of intersection to the center, to the line joining the point of intersection to the center. So the line joining the point of intersection to the center, to the center, to make equal angle with the chord. Make equal angle with the chord. So means you have to prove this, that this angle and this angle are equal. So again, draw a perpendicular line. So draw a perpendicular line. Suppose this is M, this is E, this is N. So draw the perpendicular line on the chord. So you can again you can prove. So what you can do, you can prove that the triangle OME will be congruent to the triangle ONE by using RHS. Previous question already we have done. Once you prove that, then automatically that the triangle MEO will be equal to the triangle NEO. So there's no need to put much brain on that part. Automatically, you can easily prove that the two triangles are congruent. You can easily prove that part. Okay. Very simple question. Now question number 4. Question number 4. Question number 4. So you can see this figure. So if a line intersect two concentric circle. So let's see. Here you cannot do anything. Okay. So if a line intersect two concentric circle, here if question number 4, if the line intersect two concentric circle with the same center, I hope you understand what is concentric circle. Two circles having the same center but unequal radius, they are concentric circle. If a line intersect two concentric circle with the same radius, with the center O A, there's a A, so the center is O and there's a point of intersection there, A B C D. Prove that AB is equal to CD. It is very easy. So if you draw a perpendicular line from the center on the chord, so it will always bisect the chord. So very simple concept. So so here is like this. So this is circle and this is circle. So this is center, suppose O, and this is suppose, so this is A B C D, A B C D. This is A B C D. So prove that AB is equal to CD. Prove that AB is equal to CD. So from center, draw a line perpendicular. So from the center, draw the line perpendicular. So if you draw a line perpendicular, suppose this is point E. So you know that it will bisect the chord. You know that. So consider the chord BC. Consider the chord BC. If you consider the chord BC, then BE will be equal to EC. Very easy. Okay, similarly, if you consider the chord AD, if you consider the chord, if you consider the chord AD, so then you can see that AE is equal to ED, and in that I can say A is equal to ED. So in that I can say AE minus BE is equal to ED minus EC, and you know that so B is equal to EC, so I can say that AB is equal to CD. Then now question number 5. Now question number 5. Question number 5 is like this. So three girls are there. Reshma, Salma, and Mandeep are playing a game by standing on a circle of radius 5 meter and drawn in a park. Reshma threw a ball to Salma, Salma to Mandeep. So the Reshma to Salma. So suppose this is the circle. So the Reshma to Salma, Reshma to Reshma to Salma, Salma to Mandeep, and Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep, if the distance between Reshma and Salma, so if the distance, so three girls are there, they're standing on the three circumference. Suppose this is Salma and this is Reshma and this is Mandeep. So if the distance between Reshma and Salma is 6 meter and the distance between Salma and Mandeep is 6 meter. So what is the distance between Reshma to Mandeep? So this is what you have to identify. So suppose this is the center of the circle. From the center of the circle, if you join this is 5. Suppose this is x. This is x. Suppose you draw perpendicular. So this is 5 minus x. Okay. And from the center of the circle, if you draw a perpendicular, it will bisect the chord. So if this is y, so this will be y. So you have to find this 2y. You have to determine. You have to find 2y. Okay. Okay. So here you know that 5 square equal to x square plus y square. So here you know that 5 square is equal to x square plus y square, and then you know that 6 square is equal to y square plus 5 minus x whole square. So 6 square means 36 is equal to y square plus 25 plus y square minus 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 10 minus 10x. So x square plus y square is 25, that you know that. So 36 is equal to 25 plus 25 minus 10x. So 36 is equal to 50 minus 10x. So 10x is equal to 14. So x is equal to 7 by 5. X value is 7 by 5. So the x value is 7 by 5. What you have to find? You have to find y value. So you know that so, so here 5 square 25. Then so you know that 7 by 5 whole square is y square. So y square plus 49 by 25 is equal to 25. Okay, so y square is 25 minus 49 by 25. So y square is 625 minus 49 by 25. So y square is equal to 6 and 7 576 by 25. So the value of y what you are getting, the value of y what you are getting is 24 by 5. Once you get the value y is equal to 24 by 5, ultimately you have to find 2y. 2y is 48 by 5 means 9.6. The value of 2y is 9.6. Now you see this question number 6. Now see this question number 6. A circular park of radius 20 meter is situated in a colony. Three boys, Ankur, Syed and David, are sitting at the equal distance on the boundary, each having uh, each having uh, each having a toy telephone in his hand to talk with each other. Find the length of the string of each phone. So that is the next question. What do we need to discuss here? So So a circular park of radius 20 meter. So question number 6. A circular park of the radius 20 meter is situated in a colony. The three boys Ankur, Syed and David are sitting at the three equal distance on the boundary, each having a toy telephone in his hand to talk with each other. So Ankur, Syed and David are situated at three equal distance from the boundary, each having a toy telephone to talk with each other. Okay, so here the means this is a equilateral triangle. You can understand they all are sitting equal distance on the boundary. It's an equilateral triangle. Find the length of string of each phone. So so radius is 20 meter. Here the radius is 20 meter. So this is x, and this is center. From the center of the circle, radius is 20. This is x by 2. This is x by 2. This is suppose y, so this will be 20 minus y. This end will be 20 minus y. So this is a, b, c. This is d. So use Pythagoras theorem. You can say that y square plus x square by 4 is equal to 20 square. This is equation 1. So 4y square plus x square is equal to 20 square 400. 400 into 4 means 1600. This is equation 1. 20 square 400 and 400 into 4 1600. This is equation 1. Now equation 2 is x square is equal to 20 minus y whole square plus x by 2 whole square, x square by 4. So you know that this is x square is equal to 400 plus y square minus 40y plus x square by 4. So it means 4y square plus x square is given to you. So it means 4x square is equal to 1600 plus 4y square minus 160y plus x square. So divide by 4 to 4, already you got that side. So now you know that 4y square plus x square is 1600. So 4y square plus x square is equal to 1600. So 4x square is equal to 1600 plus 1600 is 3200 minus 160y. So 4x square. Hmm, so what we can do for this? This is equation 2. 1 minute. What I can do here? So here if I bought it here, this would be 3x square by 4. 3x square by 4 is equal to 400 plus y square minus 40y. Okay, so so in place of x square, so if I write this as 3x square is equal to 1600 plus 4y square minus 160y. Okay, so so I can write this as 3x square minus 4y square is equal to 1600 minus 160y. So this is equation 2. This is equation 2. So equation 1, I can write equation 1 as 3x square plus 4 3s are 12 y square is equal to 4800. This is equation 1. So now if I consider this equation, if I consider equation 1 and equation 2, if I consider equation 1 and equation 2, so 3x square plus 12y square is equal to 4800, and this is 3x square minus 4y square is 1600 minus 160y. Okay, so here if I subtract this, this is 16y square, 16y square. So if I subtract this, 3 will get cancelled. So this is 4800 minus 1600 means this is 2, this is 3200 plus 160y. So now all are divisible by 16. So I can write y square is equal to 16 to the 32, 200 plus 10y. So I can write y square minus 10y minus 200 is equal to 0. Now I'll get a quadratic equation. So 200 means 40 and 50. No? So y square minus 50y plus 40y minus 200 is equal to 0. So y minus 50 plus 40 is equal to y minus 50 is equal to 0. So the y value you get is 50. Once you get the y value, what you have to find here in this question, what you have to find in this question, you have to find the length of each phone. You have to find the x value. So what is x? So you got the y is 50. Now what is the value of x? So what is the value of x? y is 50. So you know the equation. 4 into y is 50, no? So y is 50. So y is 50. So if y is 50, so what is 50 square? So so here y is 50. 50 square means 4 into 50 square means 2500 plus x square is equal to 1600. So means 25. So so hmm, so this is okay. So y square plus so y is 52500. Hmm, 4 400. Mm-hmm. Something is wrong. 1 minute, something is wrong here. Hmm. Let me do this question again. So this is like this. The circular park of radius 20 meter is situated in the colony. Three boys, Ankur, Sayyed and David, are sitting at the three equal distance on the boundary, each having a toy telephone in his hand to talk with each other. Find the length of the string of each phone. Okay, so here when you talk about, so this is the question. This is this is A B C. This is equilateral triangle. You know that part, right? Okay. So once you know that part, this is equilateral triangle. The radius is 20 meter. Okay. So here triangle ABC is equilateral triangle. Triangle ABC is the equilateral triangle. Triangle ABC is the equilateral triangle. Three boys, Ankur, Sayyed and David, are sitting equal distance. The boundary, each having toy telephone. Find the length of the string of each telephone. Okay. So this is the center of the circle. Okay. Now the radius is given to you 20 meter. So the radius is given to you 20 meter. Suppose this is 20 meter. This is per, if you draw a perpendicular, so then this would be a by 2. You know that this is a by 2. Okay, this is a, this is a, and this would be 60 degree. So in the case of equilateral triangle, the circumcenter and the incenter all lies at the fixed same point. Okay, so the circumcenter and incenter all lies at the same point. So this is a by 2, and this, how will you find this length of the chord? AD, so this and this are equal. Mhm. Now, so here we use the property of the, here we use the property So here we use the property of triangle. So for equilateral triangle, for the equilateral triangle, if I use it for equilateral triangle, the altitude for the equilateral triangle, the altitude and the median are same. So the altitudes and medians are same. Okay, and you know that so here uh, ortho center, here the ortho center will be equal to the centroid. Here the ortho center will be equal to the centroid. So here AO is to uh, suppose this is D. So here AO, suppose this is AO is to OD. That will be 2 is to 1. That will be 2 is to 1, and so the OD will be equal to 1/3 of AD. Okay, and if you want the value of AD, so you can again prove it through Pythagoras theorem. So you can prove it through Pythagoras theorem. So you know that this is A, this is A by 2. So you know that this AB is A and BD is A by 2. Okay, so the value of AD, if you use Pythagoras theorem, so you will get root 3 by 2 of A. Correct now. So the value of D, you use Pythagoras theorem, under root of A square minus A square by 4. So inside root 3 A by 2. So this is OD. So OD will be equal to 1 by 3 of root 3 by 2 of A. So OD will be equal to uh, that would be 2 root 3 of A. So that would be the value of OD. That would be A by 2 root 3. So you got the value of AD as A by 2 root 3. This is the value of AD, A by 2 root 3. So once you get this value, find the length of each string. What is the value of A? So you use Pythagoras theorem. So A by 2 root 3 square plus A by 2 square is equal to 20 square. So this is A square, 4 into 3, 4 3s are 12, plus A square by 4 is equal to 400. So means this is A square plus 3A square means 4A square by 12 is equal to 400. So this is A square is equal to 1200. A square is equal to 1200 means 10 root 12. 10 root 12 means 10 root 12 means A is equal to root 12 matlab 2 root 3, so means 20 root 3. This is the value of A. Okay everyone, so I hope you understood this. Then sorry, so this much we'll do for this class. We'll continue discussion from this angle subtended by the arc of the circle. We'll discuss this in our session number 3. I hope you have understood what all we have done till now. So don't forget to click on the like button, and feel free to give your comments, good, bad, whatever you feel about the class. So feel free to give your comments about the class. Your comments, your likes and dislike button, all are most appreciable. So thank you everyone for listening to me. So God bless you. Take care everyone. Bye.